Wow, hello guys, welcome back to my channel. You're welcome to Master Builders Online Academy. You're welcome, you're welcome, you're welcome. I want to sincerely appreciate every one of you who have been coming to this channel to watch and then to learn from our platform. You guys are really amazing. You're wonderful. For subscribing to our channel, thank you very much. For watching our content, thank you very much. And for even giving us positive comments, thank you very much. For being on our back, thank you, thank you, thank you. So guys, in this video I'll be showing you again how to apply the continuity equation. Yes, how to apply continuity equation. How to apply continuity equation. So you will stay tuned so that at the end of this video you won't be able to learn everything you need to know about the application of continuity equation. So without wasting much of our time, let's dive into the business so I can start blowing up your mind again. Now guys, welcome again. Now we have the very first question before us, and then we have a problem. And now let me read the question to you. As you can see on the screen, the diameter of a pipe at section 11 and section 22 are 200 mm and then 300 mm respectively. If the velocity of water flowing through the pipe at section 11 is this, now determine the discharge through the pipe and then velocity of water at section 22. Now we have the diagram before us as stated. Remember from the question we were told that the diagram is shown below. All right, so this is what we have. This is the diagram. This is section 11 and then this is section 22. As you can see here, section 22, section 11. All right, now this is the direction of the flow flowing. This arrowhead is showing that this flow is from section 1 down to section 2. So guys, because this channel or this pipe as we have it is one pipe, whatever that enters through section 11 is the same thing that will be discharged at section 22. That means the flow or the rate of flow at section 11 is equal to the rate of flow at section 22. So now let's begin. In other words, at section 11 we will bring out the parameters, and at section 22 we will equally bring out the parameters. All right, so now at every section, one of the things you must know is that since this is continuity equation, at every section there are three things that you have. One is discharge, all right, then the second is velocity, while the third is the diameter of the pipe, which will actually give birth to the area of the pipe at that section that is particularly mentioned. So as we have it now, here we have Q, here we have V, and then here we have D, which is diameter. All right, so we can call this D1, this V1, and then this Q1. The same way at this end we have Q2, we have V2, and then we have D2. All right, so this is it, and now you can see the direction of the flow right here on the screen. So what do we need to do now? From this particular question, we were given the respective diameter for the two sections, right? So we're given diameter 1 as 200 and diameter 2 as 300. So we have this as given that D1 is equal to 200 mm, and mind you, we will not be solving with 200 mm, we'll be solving in meters. So to convert 200 mm to meters, all we simply need to do is to divide 200 by 1000, and if we do that we'll have 0.2 now in meters. Are we there? Then we have D2, and that was giving us 300 mm, and then if we convert 300 mm again to meters, we divide by 1000, we'll have 0.3 meters. And again we're given that V1 is, now let's look up. As we can see here, the velocity as the pipe as section 11 is 4 meter per seconds. So that means here we have this as 4 meter per seconds, but V2 is not known. So this is what we have. Now from the question we are asked to find the discharge through the pipe and then also the velocity of water at section 2. So the first thing you want to do is to record the equation of discharge. Discharge, normally Q is given as area multiplied by the velocity of flow. This is the general equation, but because of the nature of this pipe, Q1 is equal to Q2 because this pipe is 1. Whatever that enters through Q1 will definitely be discharged at section 2. Are you there? Whatever that enters through section 1 will be discharged. Whatever discharge that enters through section 1 will also be discharged at section 2. It shows that Q1 is equal to Q2. So now one thing about this is that if I call this Q1, that means this become Q1 is equal to A1 V1, and also Q2 is equal to A2 and then V2. So what are we going to do here now? We are asked to find two things at a time: the discharge through the pipe and then the velocity of the water at section 2. So the first thing we'll do now is that since we are given the diameter at each section, we need to find the area at each section. So we'll start by area 1. Now, being that this pipe is circular in nature and we are given diameter, we are going to use the area of a cycle. Okay, so we have area 1 is equal to pi d1 squared all over 4, and this will give us pi over 4 multiplied by 0.2 squared, and then when we input this in our calculator, our answer will be 0.0314 meter squared. All right, so now we have obtained area 1. Again, we have diameter 2 as 0.2, so we also find area 2. All right, so area 2 is equal to pi d2 squared all over 4, and then we have pi over 4 multiplied by 0.3 all squared, and then when we find this result, we'll have this as 0.070 meter squared. Now that we have gotten the area, we'll now come to this discharge. Now, if you check discharge 1, Q1 is equal to A1 V1. Then Q2 is equal to A2 V2. So as we can see now, we know area 1, we know area 2, then we know velocity 1, but we don't know velocity 2. That means for us to be able to find the discharge, we will use the one I will tag as equation 1 now, right? So assuming we tag this as equation 1, and then we tag this as equation 2. Equation 1 now, we'll be able to find discharge here because we know area 1 and as well we know velocity 1. If this is clear, all we just need to do now is to apply area 1 to find our discharge. Don't forget, once we know Q1, we actually know the discharge flowing through the system. So we just recall that discharge this is A, right? Q is equal to Q1, which is A1, then V1. And then what is A1? A1 is 0.0314 multiplied by, what is the velocity 1? The velocity 1 that we're given is 4. And when we multiply this becomes mq per seconds. This is the unit of discharge. And then when we multiply this, our resulting value becomes 0.01256 mq per second. So guys, this is the answer for the discharge. This is the answer for the discharge. Now that we have been able to find the discharge, all we just need to do now is question number 2. We are actually asked to find the velocity of water at section 2. So we just recall now also to find number 2, which is the B part. We are now asked to find velocity, right? Which is velocity 2. This is what we are asked to find. So to be able to find this, we need to recall that Q2 is equal to A2 V2. And now if we make V2 the sort of formula, we then have V2 is equal to Q2 all over A2. And now we know that Q2 is the same thing as the discharge. Remember, from this equation here, we have that Q1 here is the same thing as Q2. Q1 is equal to Q2. Q1 equal to Q2. So if this is true, then it shows that whatever value we have for Q1, we can apply it for Q2. Hence, we have that this is equal to 0.11256 all over the area is 0.070 All right. Remember, we are using the area for section 2, which is A2, and then this is what we have here. All right. Okay, so if we move down, we have V2 automatically becomes 1.77 meter per second. This is the velocity of discharge at section 2. All right, so guys, therefore Q is equals to 0.1256 mm³ per second, and then V2 is equal to 1.77 meters per second. So these are the two results that we're asked to find or calculate for in this question. So as you can see, it is actually very simple for us to solve these problems. All right, so we have been able to obtain the discharge through the pipe, and then we have been able to find the velocity through this section 2 too. So very quickly, we shall be diving into another question again that will require us to use the equation of continuity, and that will be question number 2 for this video. So guys, if at this point you are yet to subscribe to this channel, do consider subscribing to our channel and ensure you turn on the post notification bell for more educative content like this. Now, without further ado, let's dive into question number 2. All right guys, now we have question number 2 again before us, and then let's read through the question. As you can see on the screen, a pipe 1 550 mm in diameter branches into 2 pipes 2 and pipe 3 of diameter 350 mm and 400 mm respectively, as shown in the figure below. If the average velocity in the first pipe, which is pipe 550 mm diameter, is 12 meter per second, the question is determine the discharge through that same pipe, and also you are to determine velocity in pipe 400 mm diameter if the average velocity in 350 mm diameter is given as you have it to be, which is 5.6 meter per second. Guys, this question at all is not different from the one we saw before, not at all. All we need to do here now again is to ensure that we understand this system. So first of all, we can see the diagram as shown to us. So like I said earlier, anytime you are dealing with the equations or you are dealing with pipe flow, which is continuity equation, you must understand that at every section of the pipe you have 3 properties. All right, so we'll start from the first section. Okay, we'll start from the first section. So at the first section, we have here Q1, then we have V1, then we have D1. Okay, for the second section again, which is the branch, here we have Q2, V2, and D2. Then when we come to pipe 3, we have Q3, V3, and then D3. So this is what we have. And whenever diameters are known, it is always possible to find the areas. Okay, very possible to find the areas. So what do we need to do now? For us to be able to find the Roman figure 1, we need to first of all deduce the necessary equations that we have here. Very important. We need to deduce the necessary equations that we have here. So now let's extract the given parameters so that we will know where we'll start solving from. Okay, so given that diameter 1 is given as 550 mm, and then if we convert this to meters, we have 0.55 meters. Then diameter 2 is given as 350 mm, and then if we convert this to meter by divided by 1000, we have 0.35 meters. Then diameter 3, we are given that this is 400 mm, and if we divide by 1000 again, we have 0.4 meters. So we have been able to extract the diameters and then convert them to their equivalent values in meters, right? So the next thing now is that we need to extract the velocities that are given, and then so we can also know the ones that are not given. So let's divide this section into two. So we start by velocity 1 is given as 12 meter per seconds. Velocity 2 is given as 5.6 meter per seconds. Then velocity 3 is unknown. All right, so this is unknown. So when we look at the question now, we are asked to find discharge through pipe 550, which is diameter 1, right? We are to look for the discharge flowing through the diameter, so 550. So how do we get to obtain this? So the first thing we'll do is to deduce the equation of flow from this diagram. First of all, we need to understand that for as long as we have these parameters given, we can actually deduce the equation of flow. Okay, so first is that Q is equal to area multiplied by velocity. Okay, so if this is Q1, this will be A1, and then this will be V1. If this is Q2, this will be A2, this will be V2. And then if this is Q3, this will be A3, and then this will be what? V3, right? So now, what do we need to check here? Remember, when you come to this diagram, the discharge is flowing from section 1, and then when it gets to a point, it now divides into section 2 and section 3. That means the discharge that is coming from section 1 is what sum up to give us Q3 and Q2. Are you there? So if what is coming from 1 is divided into 2, that means we need to add Q2 and Q3 to get the total discharge that enters through section A. So if this is clear, all we need to do now is that Q1 is equal to Q2 plus Q3. All right, so this is equation 1. Now, if this is equation 1, so we put this one somewhere. Okay, all we need to do now is to find the areas for this section. It will make it easier for us since the equation that we have here is area multiplied by velocity. All right, so to find area, we have area 1 is equal to pi d1 squared all over 4, and then this will give us pi over 4 multiplied by 0.55 squared. And when we put this into, and then we'll have this as 0.238 meters squared. All right, so we have gotten area 1. Then to find area 2, this will give us pi d2 squared all over 4. And then we have pi over 4 multiplied by then 0.35 squared. And then this will give us 0.096 meters squared. Then area 3 will also give us pi d3 squared over 4 is equal to pi over 4 multiplied by 0.4 all squared. And then when we also compute this with the help of our calculator, we'll have this as 0.126 meters squared. So guys, we have been able to find the 3 areas. So how do we now find our discharge through the pipe 1? Are you there? How do we find discharge through the diameter 550 mm? Of course, like I said earlier, for you to be able to find discharge, you must ensure that the velocity for that pipe and the area for that pipe is known. And of course, as you can see now, we know velocity 1. Okay, as you can see here, we know velocity 1, which is 12 meters per second. And then we know area 1, which is 0.238 meter squared. All right, so since we have gotten this, to find the discharge, let's have this done. So number 1 question is that we should find the discharge. So question A, discharge, which is Q1. So we understand that Q1 is equal to A1 V1. And then what is A1? We just know that A1 is 0.238 multiplied by velocity 1 was given to be 12. And then when we multiply this out, the discharge would have given us 2.856 meter cube per second. So this is the discharge. You see that this thing is very, very simple. Very, very simple. It's something that is very, very simple. Okay, haven't done this. What's the next option? Next option, when we come up here, we'll see the question. All right. So when we come up here, B, we are asked to find the velocity in pipe 400 mm diameter, which happens to be what? D3, which is pipe 3. So for us to be able to find that in pipe 3, that means we need to know the area. For us to be able to find velocity in pipe 3, we need to know the area in pipe 3, and then we know the area, but we don't know the discharge. So how do we get the discharge? Again, when we come to section 1, we already know the discharge. When we come to section 2, what will enable us find the of section 2 are given. Get it clear? The diameter of section 2 is given. Are you there? Then the velocity for pipe 2 is also given. Just as the diameter is given, the velocity is given. And then from the diameter, we have been able to find area 2. And then we know the velocity for this pipe. That means we can also find the what? The discharge for this pipe. So we just come up here and have B, velocity 3. We are looking for V3, okay? So for us to be able to find this now, we need to know discharge 3. But we'll not be able to know discharge 3 since the parameters to enable us find discharge 3 are not given. So what do we need to do? We will find discharge 3 from equation 1. We already know discharge 1. From this equation now, equation 1, we know discharge 1. We don't know discharge 3, we don't know discharge 2, but the parameters that will help us find discharge 3 are already given, like I stated before. So let's find discharge 2. By the time we get discharge 2 and put the value there, we can find discharge 3. All right, so we move down. So now recall, know that Q2 is equal to A2 V2. And now what is A2? When we check now, area 2 is 0.096. As you can see here, 0.096. Okay, so we have 0.096 multiplied by 5.6. This is the velocity for section 2. So when we multiply this product of these guys, then our answer becomes 0.5376 meter cube per second. So we know discharge 1 and then we know discharge 2. So from equation 1 now, we can find discharge 3. So what we need to do now from equation 1 is to make discharge 3 the subject of formula. And if we do that, if we take discharge 2 to the left-hand side, we'll have it as Q1 minus Q2. So therefore, Q3 is equal to Q1 minus Q2. And then we know that Q1 is 2.856 minus Q2 is 0.5376. Are we there? So after getting this, if we subtract this guy from this, our answer becomes 2.3184 meter cube per second. So now guys, we have been able to find discharge 1, discharge 2 and discharge 3. So for us to be able to find velocity 3 now, it will be very easy for us since we know discharge 3 and then we know area 3. All we just need to do is to recall. Now we want to find V3. So recall that Q3 is equal to A3 then V3. So what we need to do now is to make V3 the study of formula, and then V3 will give us Q3 all over A3. And now what is Q3? We have 2.3184 then divided by area 3. As we scroll up, we have that area 3 is 0.126. Can you see it here? Hope you can see it here. So 0.126. Then if we put in the value 0.126, then V3 is equal to 18.4 meter per second. So this is it. Are you there? So we have been able to find from the question we're given, we're asked to find discharge through pipe 1 and then velocity through pipe 3. Are you there? So from here now we have gotten all of these things here. We went through listing out the parameters, then stating the equation of continuity, then we deduce the equation from the flow that we had, then we calculate area 1 since the diameter is known, area 2 since the diameter is known, and area 3 since the diameter was known as well. All right, are we there? Then we calculated for the discharge, which was the first question. Then question number 2 said we should calculate for velocity, and we needed to do this first by calculating for Q2 that will help us calculate for Q3, which is discharge 3. Having obtained discharge 3, we just record that Q3 is equal to A3 V3, and then when we make V3 sort of formula, we simply divided Q3 by A3, and then when we put in the values, we have this as 18 point whatever we have here. So finally our answer for this becomes our results. Therefore Q1 is given as 2.856 meter cube per second, and V3 is 18.4 meter per second. So this will be all for now, guys. So this is how these problems are solved. Very, very sweet and very, very simple. So very quickly again, guys, we have a more complex problem that we really need to pay attention to again. So guys, without further ado, let's slide into question number 3 as I unveil how these problems are solved again. Thank you. All right, guys, now we have another question, and then this happened to be question number 3. As you can see, this particular question is very, very complex, as you will see on the screen, right? So but it's nothing to scare you at all. It's just a simple analysis. The same equations that we use in solving question number 1, question 2 is the same equation we will be using again to solve this particular question. So guys, let me quickly put you through on how to solve this problem. As you can see on the screen, we have water flows through a pipe as shown below of diameter 1, D1 as 50 mm, which is in series with pipe BC, as you can see on the screen, right? If at all you can't hear me very clearly, you can see the diagram on the screen, okay? And then with diameter D2 as 75 mm, in which the mean velocity of that pipe is 2 meters per second. At C, as you can see, the pipe forks and one branch CD is diameter D such that the velocity V3 is 1.5 meters per second, and the other branch CE is of diameter 4 D4, which is 330 mm in diameters, and conditions are such that discharge Q2 from BC divides such that Q4 is equal to 1/2 over Q3. Now the question is calculate Q1, V1, Q2, Q3, D3, Q4 and V4. So the parameters we have to calculate here are very, very much, but that shouldn't be a problem. The first thing that you gotta do here is to understand that at every section of this pipe, as we can see, we have 4 pipes, right? At every section of this pipe, we have discharge in each, we have diameters in each, and as well, we have what we call the velocity in each, okay? So let's get started by solving this problem, okay? Now, we can list the parameters here. Here we have Q1, V1, and D1. So here we have Q2, V2, and A2 for this pipe. For this other pipe, here we have Q3, V3, and D3. Are you there? Then for this pipe, we have Q4, V4, and D4. All right, so let's get started by having to know that we are given some parameters, okay? So given that D1 is given as 50 mm, which is equivalent to 0.05 meters, then D2 is given as 75, as you can see from the question, 0.075 meters. Then D3 is not given, then we're asked to look for that. And then D4, as we can see from the question again, D4 is given as 30, as you can see here, 30. All right, so we have that D4 is equal to 30 mm. And now if we convert this to meters, it becomes 0.03 meters. Now, having done this, the next thing we want to do is to also list the velocities given. So we divide this section into two. We're given that V1 is unknown. V2, as you read through the question, as you can see from here, V2 was given as 2 meters per second. V2 is given as 2 meters per second. And then V3 is given as 1.5, but V4 is not given. Okay, so we'll have V2 is 2 meters per second. V3 is 1.5 meters per second, and V4 is unknown. Okay, now we want to quickly get the discharge equation. Having listed the given parameters, let's quickly recall the general equation. All right, so we'll recall that Q is equal to AV. Are you there? So it shows that if this is Q1, this will be area 1, and then this will be velocity 1. If this is Q2, this will be area 2, and this will be velocity 2. Just like that, and so on and so forth. So what we need to do now is to come to our diagram and quickly deduce the equation of flow. Now, from discharge 1, from section 1 or pipe 1, which is AB, pipe AB, you find out that we have a discharge, and then which we call Q1. Whatever that comes through pipe AB is what we enter pipe BC. Are we there? So if this is clear enough, haven't been able to get this, all we just need to do now is to get this equation. So first is that Q1 is equal to Q2. We'll call this equation 1. Again, we have, if we come back to this section again, this diagram, we can see from here that with the discharge we have at 2, section 2. Now, the discharge we have at parameter 2 is what divides into pipe 3 and pipe 4. So what do we need to do? It shows that Q2 will be equal to the sum of Q3 and Q4. Hope you can see it that way, just like the problem we solved before this correct problem. Whatever that is in pipe 2 is what divides into 2 branches, one to pipe 3 and the other to pipe 4. So we quickly need to sum up Q3 and Q4 to get our Q2. So we are still deducing relationship. As we move further, Q2 is equal to Q3 plus Q4. And then this will give us equation 2. Now again, from the question, if you look at the condition here, we are told that the relationship between Q3 and Q4 is such that Q4 is equal to 1 over 2 times Q3, half of Q3, as you can see on the screen right here. All right, so we'll bring that equation again. We're given that Q4 is equal to 1 over 2 Q3, which is same thing as 0.5 times Q3. We'll call this one equation 3, right? Now, for us to reduce this equation further, since we already know Q4, all right, then we can come to equation 2. Anywhere we see Q4, put in this 0.5 in place of Q4, so that Q2 from equation 2 becomes Q3 plus 0.5 Q3. All right, so as you can see now, in place of Q4 in equation 2, I just put in equation 3 now. All right, so that Q2 becomes 1.5 Q3. This we will call equation 4. So guys, haven't gotten to this level where we'll be able to get the relationship between all these charges. Remember, this is very, very important that you get the relationship between the discharge. All right. So all we need to do now is to get the area of this section. Remember that the diameters are given except the diameter for pipe 3. All right. So let's get the areas as we have it now. Let's quickly calculate for the areas. So we have areas. Area 1 will give us pi d square 1 over 4. And then we have pi over 4 multiplied by 0.05 squared. Are you there? So this is what we have. And then if we multiply this and solve for this area, we'll have 1.963 times 10 raised to the power of -3 meter squared. All right, so we are done with area 1. Then we'll come to area 2. Area 2, the diameter is 0.075 in meters, right? So we have A2 is equal to pi D2 squared over 4. And then this will give us pi over 4 multiplied by 0.075 squared. And then if we multiply this again, this will give us 4.418 times 10 raised to the power of -3 meters squared. Then for pipe diameter 3, we have pi d cube squared over 4. But as you can see from the question, d3 is not given, right? d3 is not given. So since d3 is not given, as you can see here, d3 is unknown. Then we move to d4 so that we can get the area for section 4. All right, so we move down. Now, area 4 will give us pi d4 squared over 4. And then this will give us pi over 4 into 0.03 squared in meters. And when we calculate for this area, this will give us 0.0707 times 10 raised to the power of -3 m raised to the power of d squared. So guys, we have been able to get the areas for all of these pipes. So now we'll come back to the question. The very first question that we have here is to find Q1. And now remember that, like I stated before, that for us to be able to find any discharge, we must know the area of that discharge and as well the velocity of the discharge. So as we can see now, the velocity for discharge 1 is missing and the discharge 1 is missing. So it shows that we cannot first calculate for discharge 1 or velocity 1. We can look for another pipe that has velocity known and area known, and that pipe is pipe 2. So I hope you understand it now. So we'll just calculate for pipe 2. So the first thing we'll calculate for is Q2 because it is the one whose parameters to obtain the discharge are given. All right, so we'll now state to find Q2. To find Q2. So we have that Q2 would be equal to A2 then V2. And now what is our area 2? Area 2 is 4.418 times 10 raised to the power of -3 multiplied by. Now if you check up here, you will find out that the velocity for section 2 was given as 2 meters per second. So we need to multiply that. Okay, so let's move down. We have 2 meters per second. So now when we multiply this, our answer becomes 8.836 multiplied by 10 raised to the power of -3 meter cube per second. So guys, we have been able to find Q2. Haven't obtained the value of Q2, guys. We can now find Q1 from where? From equation 1. Remember that from equation 1, as you can see here, we are told that Q1 is equal to Q2. So having known the value of Q2, that means the same value for my Q2 is the same value for Q1. Hope you understand that. So all I just need to do now in applying equation 1, I will just say, okay, again, to find Q1, are you there? So you just recall that Q1 is equal to Q2, and then Q1 What is our Q2? 8.836 times 10 to the power of negative 3 meter cube per seconds. So guys, this is Q2, this is Q1. We have been able to find, from what we are asked to calculate for, we have been able to find Q1 and Q2. Now, for us to find velocity 1, recall, now that we know 1 and then we know A1, it is very, very possible for us to find V1, right? So I will now state here, to find V1. Recall that Q1 is equal to A1, then V1. So if I make V1 the square root formula, we are going to have this as Q1 all over A1. So guys, all we need to do now, this is 8.836 times 10 to the power of negative 3 all over A1. So let's move up so that we can get area 1. Just check it here. Area 1 is 1 point, as you can see it here now, is 1.963 times 10 to the power of negative 3, as you can see, right? So we just put in the values. So we have 1.936 times 10 to the power of negative 3. And the answer for this would have given us 4.50 meter per seconds. So we have been able to find velocity. Guys, let's move up to the question as then, so we can know what we have found so far and then what is remaining. So we have been able to calculate for Q1, Q2, V1, right? Then we are left with Q3. Now that we know Q1 and Q2, we can find Q3 from equation 4. Can you see it? Can you see it? In equation 4, we have Q2 and Q3. Q2 and Q3. So I can find Q3 from equation 4. Hope you can see this. All we just need to do now is to make Q3 the square root formula by dividing Q2 by 1.5. It's as simple as that. So let's take that. To find Q3, first is to recall that Q2 is equal to 1.5 Q3. Are you there? This is what we had from equation 4. So all we just need to do now is to make Q3 the square root formula. And if we do that, this becomes Q3 is equal to Q2 divided by 1.5. And now what is our Q2? Our Q2 is 8.836 times 10 to the power of negative 3 all over 1.5. And then we have Q3 is equal to, I hope you are following me, 5.891 times 10 raised to the power of negative 3 meter cube per seconds. So guys, this is the result for Q3. Now, having obtained the value of Q3, if we move up to this question section, we are asked to find D3, right? So we can now find our D3 by first of all recalling the equation that connects D4 to V4. It's as simple as this. So all we need to do now again is to say to find D3. Find D3. All right, so you recall that Q3 is equal to A3 V3. Now, by extension, we recall earlier that A3 is pi D squared all over 4 V3. So remember now that we are looking for D3. So what we need to do now is to find a way to make D3 the square root formula. And from here, if we make D3 the square root formula, we'll have that. If we do that, we have D cubed squared is equal to, first we multiply 4 by Q3, then divided by pi V3. And then when we make D3 the square root formula, we have the cube root of 4Q3 all over pi V3. All right, so in order to find D3, we just put in the values 4 times. So we check up here. What is our Q3? Look at it here. Q3 is 5.8 8 5.891 times 10 raised to the power of negative 3 all over pi multiplied by V3 as we were given from the question. You can check it here. V3 was given as 1.5. All right, so look at it here. V3 is given as 1.5. Can you see it? So let's move down and put in the value of V3. So we have 1.5. And then V3 becomes the cube root of 5.0 times 10 raised to the power of negative 3. That's if we find the square root. And then D3 is equal to 0.071 in meters. But remember that the values that were given earlier were all in millimeters. So that means we can convert to millimeters by simply multiplying this value in meter by 1000. So if we do that, D3 automatically becomes 71 millimeters. All right, so this is it. But whenever we want to use D3, we will use 0.071. But now to convert to millimeters, because other diameters we are given in millimeters, we simply have to do what we have done so far. I hope this is getting interesting and then you are gaining massive values for this channel. So if you are yet to subscribe to this channel, guys, consider subscribing to our channel and do encourage us so that we will keep uploading mind-blowing content that will be helping you to balance up your academic pursuit, right? So now let's move up and see what next we are asked to look for. Now the next thing we are asked to look for after getting D3 is to look for Q4. Now for us to get Q4, we need to get all the relationship between the Q's and see the one that relates to Q4. Now as you can see from the equation, we were told that Q4 is half or 0.5 times Q3. You see that this thing is very, very simple to solve. All right, so what we just need to do now is to divide Q3 by 1/2 or divide, yes, it's just to divide Q3 by 2. Are we there? So this is what was given to us in the equation. So we'll now simply say, so you come up here and say to find Q4. Now recall that Q4 is equal to 1/2 Q3, which we also extend earlier as 0.5 Q3. So this will give us 0.5 multiplied by what is our Q3? When we calculated for Q3, we had Q3 as 5.891 multiplied by 10 raised to the power of negative 3. I hope you can see this very clearly. Hope you can see it very clearly. So by the time check up here, you see that this is Q3, as you can see here, this is Q3. So that's the value we just substituted there. Okay, now when we move down to find this, the answer for Q4 automatically becomes 2.946 meter times 10 raised to the power of negative 3 meter cube per second. So this is the answer for the discharge Q4. So guys, as you can see now, the only thing that we are left with is V4, which is very, very simple. That's the only thing among the parameters we are asked to calculate for. Only V4 is left. So how do we get V4? Since we know area 4, as you can see here, area 4 is known, and then we know Q4, to find V4, it will not be a problem. So now, let's do this. To find V4, recall that Q4 will be equal to A4 V4. So let's quickly make V4 the sort of formula so that we can divide Q4 by A4. And then all we need to do is, what is Q4? As calculated, we have Q4 as 9.2.946 times 10 raised to the power of negative 3 all over area 4 is 0.0707 multiplied by 10 raised to the power of negative 3. And then when we calculate for V4, the answer becomes 4.16 8 meters per second. So this is what we have so far. This is what we have so far. This is what we have so far, as you can see. So guys, from this analysis, we have been able to show you again exactly how to solve problems of this nature. So in this video, I've held you by the hand as promised and show you exactly how to solve problems under equation of flow or using the continuity equation without hiding anything from you. So guys, if you are yet to subscribe to this channel, kindly subscribe to this channel and ensure you turn on the post notification bell so that anytime we upload mind-blowing content, you will be notified. Don't forget to like this video, don't forget to share this video, and don't forget to leave a comment below. All right, so we love you. Thank you for watching. Thank you. But one of the things we need to do now is that for this particular question, we need to list out all the given parameters, all the calculated parameters. Okay, so we started by calculating for Q1, and then after calculating for Q1, we calculated for Q2 just like that. So we'll now say the answer in summary, our answers so Q1 is equal to Q2, and then both were equal to 8.836 times 10 to the power of -3. Are we there? Then we have V1 to be 4.5 meter per second. Then again we calculated for Q3, and we had that Q3 is 5.891 times 10 to the power of -3 meter cube per second. Then after which we calculated for D3, we have that V3 is 71 millimeters. Then after calculating for D3, we calculated for Q4, and then we have Q4 as 2.946 times 10 to the power of -3 meter cube per second. Then finally we just calculated for V4, and then we have V4 as 4.168 meters per second. So guys, this is all about this question. So please, if you are given this question in exam, ensure that after solving, list out the answer so that the examiner can easily see all your answers at a glance. I love you so much. Thank you for watching. Thank you for staying to this end. I wish you all the best in everything that you do. Thank you for always coming back. I will see you in the next module where I'll be blowing up your mind with another approach and some standards in engineering problems. We love you guys at Master Builders. Thank you very much. God bless you. This is meter cube per second. See you in the next class. Thank you very much. Wow, this is Master Builders on the board.